All right, today we're going to, I believe, make it so that when we run into the obstacle, we send an event that will then be caught by that enum, the game state enum, and that will then change the game state to game over, essentially. So that will be our two observers that we implement into this game. So I'm thinking here, well, let's go figure out where that is. Because we have obstacle. Let's actually see where it's done in the main library here. So we have implement, all the implements. Let's just go ahead and fold everything. And we'll take a look at, so an update. When we're in the plain state, we run the obstacles. And here, okay, so here we have if self.player.is running into obstacle. So the player checks to see if it's running into an obstacle. And it checks against both of them. So it's going to return true in either case. So it looks like we can replace this entire section of code here by having the player, if it does run into an obstacle, emit an event. Which this will be nice. Now the player and the obstacle both have to be subjects, as it were. So let's go ahead and make the player a subject. So we're using super obstacle. I think I want to say I could just do super obstacle. Which means I can also bring in subject. So we're going to impl subject for player. And then it'll yell at me about what I've not implemented here. Add observer and notify. So let's add that. So function add observer, which takes immutable self. It doesn't return anything. And then, right, you're just saying cannot find that type. And then function notify, which takes immutable self. And an event doesn't return anything either. So we need possible observer and event in the scope now. Okay, and now it's just saying that we're not using them, and that's the real problem. Which means we need to now store the observers inside the struct. So that's the one thing that the player needs to be aware of, really. And so I think that we have the that special type, which is the wrapped, not the wrapped score. It is the observers. What did I call it? Because it's the enum of observers. You're here an event. It is, oh, a possible observer, right. Oh, I guess I already have possible observer, so we're fine there. So here is observers, and this is going to be a vec of possible observer. And we'll just set this up as like empty here. I guess I'm already doing this inline on some of these, so we'll just do that here too. Observers, and that's a empty vector. And that should be everything we need to do to the player itself. Now down here, when we're implementing subject for the player, so add observer, we're going to take the observer and we're just going to push that into that vector. So I'm going to say self dot observers.push observer. And that should be it for add observer. Moving on to notify. So notify, we're going to get the event. The event is going to be some kind of event that's going to happen here. So check if running into obstacle. So instead of returning this, this will become an if statement, and then we'll call it. So let's go ahead and do that now. We're going to make this an if. So if self.location.x is less than. So if all of this happens, then we want to, what are you upset about? Expected Boolean. Right, we're not going to return anything anymore. We're just going to go ahead and check. Maybe rename this to like handle running into obstacle. And then we're going to call self.notify, and then the event is, oh, player jumps over obstacle. That doesn't seem right. Let's go ahead and add another event into here, which is player ran into obstacle. And I should be able to just immediately use it right there. Okay, so we send the event over to here. So now we have the event. We're going to need to loop through all of these observers. So we're going to clone the array of observers. They're arc mutexes. So we'll need to do a little bit of extracting for that, but it shouldn't be that big of a problem. So for observer in self.observers, I'm going to clone this. So that way, well, I mean, we're only getting the arc out of it. So we're cloning the vector of arcs, which is not really that big of a deal. And let's see. For observer and self.observers.clone. And I want to. What is it that we want to do here? We want to notify the observer. So we need to extract. We need to lock and unwrap to get the observer out of the mutex and arc. And then we can run the onNotify function on it, which will then hand it the event. I think that's it. So, what is that? That's going to be the observer.lock.unwrap. What's your problem? Not found in events possible. Oh, right. It's a possible observer. So first we have to extract it out. So if I do match, so match on the observer. I'm really curious if I could do like a star. I don't think I can. I expected like an actual pattern to match it. Yeah, I know I can do underscore for. Is underscore anything? Like everything? If that's the case, then I can just use this as a catch-all. And I don't really care what it is. I'll just shadow observer and catch it there. And then I can just say, okay, I want the observer. Lock, unwrap, on notify, and pass it in the event. I wonder if I can do this. I expected one of, ooh, no, okay, so what is match this observer It's the event's possible observer. Yeah, okay, so we have a score, and then we're gonna want... Okay, because that's who we've wrapped. This is gonna be the game state, which is a wrapped game state. What else do we need to add in here? Because these are different types. It will probably yell at me if I try to have like... I guess I need to figure out... Just use its name, whatever. Yeah, I guess I have to handle all of them. The generics would be the right answer here. I think a generic would be the best thing to do here. I do need to take a little bit of time to learn how to properly use that. Last time I tried with this pattern, I ran into some problems. But that's, I mean, it's not the worst thing in the world. Okay, so if we come back to player here, we want to do the wrapped, what is it, game state? So game state observer. Can I find tuple? What did I call it? Game state. Oh, I should probably not call it the same thing as something else here then, right? Wrapped game state. I should probably call it wrapped game state, like that. Also, physics, good morning. Cannot find tuple struct or tuple variant game state. Oh, game match observer and observer. So you are events possible observer. So in possible observer, we have game state. So I think it's a little bit confused, but I do need to bring in a game state here. Expected tuple struct or tuple variant game state. So it doesn't like this name. So let's change it. So we're, instead of game state, match the same or less behavior than if let underscore equals sum 3, don't bind value or let sum 3, bind full. I know the formatting in Twitch isn't the best. I've been like for a long time now. I've been really considering whether or not I should create a Discord server, which does have a lot better code. Like they've actually made the code really good. Like it's just as good as Slack now, as far as I can tell, for formatting messages. Yeah, so it probably is a where are we? Possible. Oh, you know what? It's possible observer. So let's switch this to a game state. Let's switch this to an if let. So if let is gonna be possible observer game state. I forgot. I need to do go in from possible observer game state because I'm not using like the use from it. And then from here we're gonna get the wrapped game state equals observer, and then here we can now do what we want to do. So this This is equals observer. We are now going to unwrap it. So we're gonna say wrap game state dot lock dot unwrap dot on notify, because I believe oh, we haven't implemented it for the next thing yet, so I think that it's going to have a little bit of problem, but that should end as soon as we finish this. So there we go. Now you're just saying no method found in this. I don't think I need to destructure it, or maybe I do. Oh, the trait. Right, we need to bring in the trait for the notify. So that's the observer. I don't know if I need, I don't remember if I need to destructure it. Let's go take a look at obstacle. Yeah, we just did observer.lock and unwrap on notify. Oh, and a reference to the event. We're taking in the full event here, and then we reference the event. And I guess that's because we're sending out to multiple people. Potentially should be a reference. This would be a reference there. It's just yelling at us because this game state doesn't implement subject. So let's go do that next. So go into game state. So this will be interesting to see whether or not we can do this to an enum. Otherwise, we'll need to change this to a struct. All right, so we're going to do use super. We need the observer. Impl observer for game state. And now it's just yelling at us that we don't have on notify. On notify, we need a mutable self and then an event. So let's bring that in next. We're not going to return anything, and then we're going to just do whatever we need to do here. So we need to check to see what the event is, and the event is an enum. So if let event, and this is going to be if the player ran into an obstacle. I don't need to check anything else. I don't need to extract anything else from that. Then I want to, so if that event, then we want to destructure, no, destructure is the wrong word there. I want to deref self and then set that equal to self game over. All right, I think that will be that for that. So now in player, you're now happy because that's working. Now, we should just be able to fix the errors from when we call in these things, and then everything will be happy. So for example here, no method named is running into obstacle found for struct player in the current scope. That's because we changed it. We no longer have to do this entire thing. Now we're going to do self.player. Where is it? Handle running into obstacle, and then pass in the obstacle. You know what would be nice if we just handed it maybe a tuple or an array of these obstacles, and then we could just call this once. We could even just say obstacle 1 and obstacle 2. I mean, I suppose we could just call this twice, and that's fine for right now. So this is going to be a reference to self dot obstacle 1 self.player.handRunObstacles, self.obstacle2. But yeah, refactoring the obstacles to be in a vector would probably be the best thing to do. There's a bunch of places where we're sort of calling obstacle twice. Okay, so that's one thing. Cannot borrow self as mutable. It is behind a reference. So this is handle run into obstacle, self.notify, and then we hand it, give it an event. Oh, because you need to be interesting. So I need this to be mute. Self is is just a reference. The data it refers to cannot be borrowed as mutable. Mute. That will work there. Okay, and all right, so variant is never constructed here, game state. Right, so now it's just saying, hey, we're never actually making a wrapped game state, a possible observer. So we need to do that. I think that's over here in the main library when we do new. So when we create here, for example, here's our wrapped score. We're gonna do the same thing for game state. When do we make you? Because we have possible observer wrapped. When do we create the possible observer? When we add an observer, right? Okay. So in our main library here, we create our. Where's our score? Here's our wrap score. And then somewhere, all right, it's in new here. So we create a wrap score, we create our observer, and then we hand it the wrap score. No, we make a possible observer, so we make a score observer. And we give ownership to the obstacle. Okay, so that's what we're doing here. I can actually move this all the way down here to make a little bit more sense here. So we need to do the exact same thing for our player. We create our player up here. And our game state now needs to be wrapped. So you need to become let's just change you up here. Game state is going to become a wrapped game state. A wrapped game state here, which means this is going to be arc new. Mutex new. And throw that in there. Okay, so now we're going to store. So we've wrapped this. We need to create the observer. So let game state observer equals. You know, I don't need to do this right here. I could just do it as I add it in. So we're going to do our player dot add observer, and our observer is going to be a possible observer game state. This is a tuple game state enum, and we're going to add in the wrapped game state, clone it as it's coming in here. because when we return our full game, we want this to be a wrapped game state. Expected enum. I changed the name of it, but I didn't change. This is going to be a possible. I need to bring in the use. Use events wrapped game state. There we go. Now we have to find where we're using this game state. And then sort of go fix this. So match self game state. So we need to unwrap it here first, and then we can go ahead and do our match. So that's gonna be fun. So I wonder if I can do this in line here. So self dot wrapped game state dot lock dot unwrap. I don't think I can get anything more out of that, because that gives me the game state. So expected struct mutex guard found enum game state. Wait, it was expecting the mutex guard? Wait, do I need to dereference it? Yes, I do. Okay, so this is where I need to dereference it when I use it here. All right, what's next? No field game state on mute my game. All right, so if we're in the game over game state, we are going to command execute. Input handler, handle input. Ooh, right, okay, so we're gonna get the command for handle game input, execute the command, hand it this game state. So we need to hand it the wrapped game state. And we probably need to clone it. We need to clone the game state and hand it in there at that time. Which means it shouldn't be a reference anymore. It should just be the full game state. So mismatch types, we're there. No. I keep on hoping that I can click somewhere in here and it will take me to where it's being used. But all right, so this is in the commands. So in here in execute, we have this game state here. This is now going to become just the wrapped game state, and it's no longer going to be a reference or a mute. It's just going to be a full ownership of it. Use super wrapped game state. Okay, so there's that. What's next? No field game state on type mute my game. And that's on. Oh, you didn't. Okay. I keep on clicking it until it opens up for me. So here we have match self.game state. So it's going to be the same thing. We're going to dereference. No, wait. Yes, dereference is correct. I keep on getting destructure and dereference like confused in my brain. We need the asterisks for dereferencing because we have a reference. Okay. And this will become a wrapped game state. Then we're going to unlock and we're going to unwrap. And by unlock, I meant lock it just for our own personal use here. that's good there. Next up, no field game state on type mutable reference my game. So here, this is on the key down. We need to match on the game state to determine what we're doing here. We do this a whole bunch. So I bet we can multi-cursor this. Let's try it. So we need to come back to here and dereference. Especially when we're setting this equal to. You are going to be the wrapped game state. We're going to lock you and unwrap you. Now, the reason why this works like all the way down like this is because we're playing with synchronous stuff. If we're playing with asynchronous stuff, this would cause huge problems for us. It would basically soft lock the game. Or deadlock the game, I think maybe is the more correct term. When we say lock, we're telling the arc we're telling the mutex, make sure that we're the only one that has mutable access to this. And halt the thread until we have that mutable access. We're in a single thread, therefore there's no problem. If we were in an asynchronous environment, it would halt the thread, wait for this, halt the thread, wait for this, halt the thread. Nothing would happen because they're all waiting for each other. So in a single thread, this actually is a little bit easier because I can control, hey, you are guaranteed to happen. You're guaranteed to happen. You're guaranteed to happen first. All right, method execute has an incompatible type. So in this method execute, so I think, right, we're gonna have to go into our trait in command trait here. Okay, so method game command, we have this execute. This is now a wrapped. So we have to use super wrapped game state. You are a wrapped game state. Now, of course, we need to do the entire thing here too. So you are a wrapped nuts. We want wrapped game state. Did I not update that in the command trait here? I did not. Wrapped game state, just like that. You're going to be a wrapped game state. And dot lock dot unwrap. And then we can run that plain function on it. All right, so cannot borrow player as mutable as it is not declared as mutable. So we have this player add observer here. Oh yes, okay, so when we create the player, we need you to be mutable. Cannot borrow dereferenced self as mutable because it's borrowed as immutable. So this here, we do have a mutable self up above. What line is this? 323. Update trees. It happens immediately after this self-player handle running into obstacle. So I think it's clearly caused by this. Cannot borrow a dereferenced self as mutable because it's also borrowed as immutable. Immutable borrow occurs at 297. Ooh, okay, yeah. So if I do this, if I dereference self, I wonder if I can. So wrapped game state. I wonder if I can clone. Let's do wrapped game state equals, and then we're gonna say self dot wrapped game state dot clone from that. Now I shouldn't need to do any of this. We're just gonna go to this new wrapped game state, lock and unwrap it. Game state plain, so mismatch types. Can I dereference this just temporarily to clone? Expected struct mutex guard found in game state. No, okay, so that didn't work. Can I do my lock and unwrap up here? If necessary. So it cannot move out of reference, so won't dereference it. Now I've cloned it. Expected struck, mutex guard found. Right, okay, so the problem is that it's still inside of the mutex. I need to get it out. Dereferencing tells it to get it out, but if I do that, I end up borrowing self as mutable, essentially a couple different times. So I clone the arc. If I do this inside of a block, so that it handles sort of like the memory access, I wonder if I can extract it in that way. So if I just have our game state, let's just create a variable here. Then we'll create a block. We'll throw this command into our block. So we have a wrapped game state. We clone. So we unlock. We lock and unwrap it. This gives us a mutex guard. Now if I dereference and clone it and set that to game state. So if I say game state equals, now I want to clone the dereferenced. So dereference wrapped game state, and then clone it. And you're going to say that there's no clone found for game state. So let's go and implement that here. Maybe I don't. Okay, and now you're saying that I am a game state. So I'm purely a game state at this point. So now we're going to wrap match on game state. Now, what are you? Temporary value dropped while borrowing. Well, we don't want that. Creates a temporary value which is freed while still in use. I want to give ownership to over here. Am I sure that I want to clone my game state? I mean, not completely sure. Because I'm in a loop here, this sort of update function loop, cloning it to basically check what is the value like right here, like right now. Then the next loop through will be another clone of it. So that's not the worst thing in the world. But it is suboptimal too. Okay, so the carc. Temporary value drop while borrowing. So self, the game state. Now if I don't clone you, we still, oh wait, okay, that works. That did it. You're right, Rizix. No cloning. Because if I cloned, I create a new value of it. If I don't clone, I'm using one that already exists on self. So I just lock it, unwrap it, extract it out. Oh, I clone it here. I don't need to clone it here if I'm cloning it here. That's it. Okay. Cloning hopefully should be pretty cheap because it's just a very small enum. It's not the best. But all right, moving down to the next thing, we're gonna have the exact same problem here. So let's go ahead and we'll implement the same solution. So let game state. We're gonna have our block here. So we're gonna say game state. I wonder if I can do this in one line here. Let's try it. I'm gonna say self dot wrapped game state dot lock dot unwrap dot clone. And then here in our match, we can now match off of game state. And there we go, magical. So I can come back up here and change this into the single liner too, which is basically just adding in a dot clone at this position and getting rid of this line and then saying game state equals. Now this block here, do I even need the block? You feel like I'm locking the mutex to create a copy of what's inside. I think you can omit the last clone. Oh, you're talking about this clone here. So if I do that, then what ends up happening here is that we get this error saying it's expecting it to be a mutex guard. And that's because game state is part of this mutex guard. So we need to dereference it to get it out. But if I dereference it, I get a mutable reference to it. And that's where I'm running into trouble. So cloning the game state allows me to basically have that as a separate have game state be the real, like what it really is. Can I do dot anything here? I don't think I could do like another lock. Yeah, no method named lock off of this mutex guard. How do I modify the real game state? That's a good question. The events system would probably be the best thing to do. What am I doing anything? Wait here, let's see. If I do this, does the game still work or does it not work at all? Not unwrap. Clone. So if I do this, let's see if the game even works. Because that's a really good question of physics. We haven't tried it with like doing this. I mean, technically it runs. And okay, the score goes up. That's fine. And does the end work? Okay, so the game over works there. Can I restart the game? I can. Okay. So that worked. Did it not? Jumped over. The trees didn't reset. I thought that's interesting. The obstacles and the player reset, but the trees didn't reset. Let's make sure if we do like 4, the end screen works still. Okay. So yes, I can modify the real game state. But it is a little bit odd that the trees aren't resetting. Although I can't remember if I properly set that up for resetting in the past. In our reset command here, we do player reset, wrap score, obstacle, wrapped game reset. You know, I don't think we ever emptied out the trees vector. And I think that's up here. We have a vector of trees, and we're just randomly adding trees. We have this like create tree at. We have the trees. We need to reset those. But besides that, like, so, yeah, the game just still works. Let's see why that is. When we're here in update, we get a clone of our game state. So the clone of our game state is then checked with this match. We get the drawable size, we apply the player force, so we update the player. We have we handle the player's input, so we deal with the jump command. We have the obstacle run and potentially hit the player. If the obstacle is off screen, we reset the obstacles. We increase the speed of the game. We have the player handle running into the obstacle. So this is where it's interesting, because the game state is not being updated in here anymore. At this point in time, the player is going to take in the reference to the obstacles, calculate if it's running into any of them, and then run this notification event that it ran into the obstacle. So when it does that, it's going to loop through all of its observers and inform them, hey, I ran into an obstacle. So we have this add observer. Where does that happen? That happens way up when we initialize the game. So here in new, we add the wrapped game state to the player as an observer. So that happens here with the original game state. And that's the reason why when the event system happens, the original game state, the real game state, gets that notification, therefore it updates, and the real game state is updated. Every single frame, we are creating a clone of that game state, and then checking, hey, cloned game state, what are you right now? Hola, Chantilly Cake. Good morning. Yeah, actually, the game state clone is not used more than that match condition. Exactly, yeah. We're just trying to determine, are we in a plane? Are we just playing right now? And that's it. Like this clone is just used here, just to match these ones, playing and game over, and help. This entire thing, like, so if I created a module, like a struct for displaying, like handling these, instead of having it in a main library, I could potentially have it be an observer. And then not have like game state itself, but instead it could just track internally what it is. So that might be an option for like having game state be a struct. Usually add information to each state variant so you are confused. Oh yeah, I mean, it's also a very different pattern than I'm used to playing with, but I've been thinking about how I can potentially use an observer pattern in Rust for this type of thing. And I think there's some interesting ideas for combining different areas of programs that don't necessarily have anything to do with each other. For example, with a chat bot, when chats come in, it can send an event out for each chat, and then I might have something else that deals with those chats, like maybe one that throws into a database, one that responds to the chat message, or one that I don't know, like makes a sound or does something else. And that way I can sort of separate them out and not have it so tightly integrated into code. Kind of makes me want to rebuild the chatbot now with like a little bit of this pattern inside of it. So that's why that works. Let's fix some of these warnings here. So we're no longer using game state in the command trait because we're using a wrapped game state. We're no longer using game state in the player because we have the wrapped game. We have the possible observer. And game state in reset game commands because we have wrapped game state. And there we go. And everything is working. No
warnings, no errors. We're able to play the game just fine. And it's all looking good. And we're still getting 59.99 frames per second, which is really good. Especially since I've always had this sort of like problems. We're running in Windows natively because that's just been faster than running in the virtual machine that I was creating. So while I'm waiting here, because I have a few minutes before 8:15, do any of you have any questions about like what we implemented, going over any code, want to see anything in specific? I can also, I believe, turn on the highlighter, so you can highlight any code you want to see. Player jumped over me. Let's remove that print. Oh, that's in the obstacle. There. Don't need that anymore. Yeah, I don't have a bot command. And let's see how this runs in release mode. Cargo run release. It's funny how in release mode it's locked to exactly the same frame rate that I have in non-release mode. Which, I mean, I suppose it's kind of funny, kind of a little bit sad. It's definitely, I believe now it's how I'm programming it, not necessarily a bug in GGEZ for Windows. Because I was able to get up to this 59 frames per second.
I guess almost like it's about 60 frames per second if we round up. There's also average, so I'm guessing that it's significantly faster, and I'm every once in a while. I'm wondering if if I can somehow like spread the work across different runs. That might be interesting too. I suppose if I change this to be a little bit faster, it could be a little bit more interesting. I could add in a bot that could play this. Just determine, hey, is it close to me? I'll just jump. It doesn't really increase. It increases super slowly. I feel like it should increase the speed a little bit faster, just like the P5.js one does. But I'm not necessarily trying to make this like a super fun game to play. Just more of an experiment with the what is it called? The design game patterns in making a game. Because like by the time we're done with this, we're gonna know how to make the architecture of the entire game better. The architecture is not necessarily gonna be in a perfect state. But we're gonna know a lot more about how, if we wanted to remake it, we could do that. Yeah, speed would be great. So much faster than the last time you've seen. Yeah, but it could even be faster. All right. Well, with that, oh, Danny Fritz, do you have VSync turned off? You need to turn off for greater than 6. Ooh, is VSync turned on by default? Let's open up Firefox Developer Edition here. No, I didn't even think to check that. I always just sort of assume that it's off by default. Let's go into GGEZ. I think there's a way in, should have a setting. That's probably explaining why I'm having such problems with this. Conf.toml should have a setting for it. I don't have a conf.toml for GGEZ in here. Documentation. I think, is it, where is VSync? It's in a Windows setup. So, Windows setup. VSync is true by default. Okay, so function VSync, and I can take a bool for that. So, let's go to main. So here we have window mode. Let's now do a Windows setup. Windows setup. Let window setup equals Windows setup. The music is a little bit too smoothing. Yeah, I need to go through and like create a playlist of like the good songs, because I've had some good songs come in the past, and then I've like right now it just seems to be, yeah, let's do like, you know, not the great stuff. I think, can I switch to, let's do try some EDM. Last few minutes of the stream shouldn't be a problem. All right, so window mode setup. We want the default. And then dot v, come on. VSync false. Okay, so we have dot window mode this, and then dot window setup. Window setup like that. And then we build. And now let's do, wait,
didn't exit successfully. Okay, I think it should be exited now. Let's just do a normal cargo run and see how this works. Whoa, okay, that was it. That was it. Now we're getting 112 frames per second at this point. So because I'm not locking this to, I'm not doing any delta time stuff, everything's screwed up now, which is fine. There's a part of the book that's going to talk about that. So we'll definitely fix that at that point. Release now. Yeah. Okay. Let's try release mode. This is 100 something. I was wondering how to get like unlock the power of my computer with this. So this is this is gonna be a little bit tough. So you can see this is the desktop can handle this. It's just me holding space down. A little bit more than is that more than, yeah, I think it's more than 10 times faster. Yeah, just hold space down and hope that you get lucky. And because I'm doing AABB, oh yeah, look how high I can jump with that. Oh man, all right. Oh wait, you know what? I'm dying a lot, but it's skipping the screen. Like I'm getting like at most like 3 points. If I had a high score here, we could then see that. But yeah, that's as Chantilly says, ship it. So that's cool. I now am gonna have to remember to do this Windows setup here, in order to get that running the way we want to. All right, which is perfect. All right. And then that is going to be really nice. It kind of makes me want to go back and try that other, the other app that I have where I'm doing the, what is it? The stress test, and add that in there. But I am out of time. You think you should still have some leftover cycles that I can use? Probably. Although that did make the fans go up a little bit. I am also at the same time doing, you know, OBS and everything else. Anyways, thank you everybody for watching. This has been a lot of fun setting up the observer pattern in Rust, getting that, you know, working. It's unlocked, I think, some interesting things for myself in future projects that I can do. I'm really looking forward to using them. If you follow on Twitch here, follow on Twitter for when I'm going to go live. I am trying to go live every single morning this week at around 7 a.m. Mountain Time, which is GMT -6 right now, I believe. And with that, I am going to go off and get ready for work. So I hope that you have a great day, and I shall see you next time. I forgot that I don't have the music on this one. So that was a pretty hard cutoff. Let's change that. Audio output capture. Here, music coming back.